Hello everyone, I'm Joaquín Lefranc. I'm a 10th semester student of Tecnológico Nacional de México Campus Instituto Tecnológico de Querétaro and co-author of the poster Optimal Condition of pH Composition and Temperature in Synthesis of Cadmium Sulfide Thin Films by Chemical Bath Deposition. Now starting with introduction. Semiconductor thin films are the type of advanced ceramic which are of high interest to science for photovoltaic application and their filtration of UV radiation. The chemical bath method for deposition of these films on substrate is based on the immersion of substrate in the solution which, with the optimal condition of pH, temperature, and concentration, and deposition time. The thickness of said film largely depends on the factor previously mentioned. The CVD technique is based on controlled precipitation of material that is deposited homogeneously on the substrate. The physicochemical process can be controlled by homogeneity reaction. Now in this image, the figure 1, in the first part, the homogeneous reaction mechanism. This is commonly known as ion by ion. In this type of mechanism, nuclei are generated which are formed on the surface of the substrate, while over the time the new nuclei form by sulfur ions and metal ions respectively are there. Now in the second part of the figure 1, we have that this is formed by heterogeneous precipitation, or also cluster by cluster. In this mechanism, a colloid solution type is formed with an intermediate such as hydroxide ions or also sulfur ions in the solution for the ground nuclei on the substrate. It occurs in the same way as previous mechanism. Now following with the method used, the reagents used in the synthesis were all those contained in chart 1, in addition to antifreeze for the water bath. These reagents used in the synthesis of the molar radius of the chart 2. Once prepared the formulation, we proceed to place each of the substrate within the beaker with the solution and measuring a test stripe the pH of the prior solution to the enter to the temperature control bath, and after removal of the last film, the deposition times for the films were 15, 30, 60, 90, and 120. At the time of removing each film, it is washed with a jet of water and material not adhered to the substrate is cleaned. The optical characterization was carried out, obtaining the absorption and transmission spectra in a range of 300 until 1100 nanometers with a HDR 6000 molecular absorption spectrophotometer. Now, in the results obtained in figure 2, shows the 9 to 1 molar ratio thin film at different growth times for 90 degrees centigrade, and the time used for these films is the following: 50, 30, 60, 90, and 120, the previous mentioned. And at the end of the figure 2 is we have the residual solution. Following with the results, we have in chart 3 the average transmittance at 480 nanometers, because it's the point of inflection most noticeable in the transmission spectra. Now in the left side we have the spectra for the whole variation in molar radius, and in the right side we have the variation for temperature. Now below the variation of molar ratio we have the graph showing doc for calculating the energy gap by extrapolating the straight portion of the line of graph versus the energy of the photon. Now, in the conclusions, growth were obtained with the pH range from 9 to 11 with values closer to 10, which better favored the growth of thin films by chemical bath deposition. The cadmium sulfur molar ratio affects the growth of the films, being higher as the sulfur concentration increases up the molar relationships with the energy gap, finding data of up to 2.72 electron volts as the molar relation between cadmium and sulfur ions equilibrates in the reactive solution. Proportion 3:1 and 6:1 and 9:1 were inefficient for the formation of coatings. Homogeneous and well-adhered observations and the characteristic of residues, the reaction mechanism that is proposed for the case is cluster by cluster. Temperature is directly related to the growth of thin films by CvD. As it decreases, the average transmission increases due to the decrease of thicknesses. 70 Celsius degrees is an optimal temperature for growth of cadmium sulfide. Now, I'm infinitely grateful to Tecnológico Nacional de México Campus ITQ for providing its facilities, since without them this investigation would not have been possible, and also the assistants who help with the management of and provision the materials. Now we have the reference. Thank you, everyone.